This is the November 2010 Paper 1 Standard Level, and it's the multiple choice. Now remember, with multiple choice you are allowed to have your data booklet, so always keep that handy, and I will try and do some extra explanation as I go along. Very important to read the questions very carefully. That's the number one thing. So which of the following is equivalent to the joule? Now, hopefully you'll know that joule is your unit of work. So if we go to our data booklet, we've got work is equal to Fs, and hopefully you'll know that F is for force, which is a Newton, and S is for displacement, which is a meter. So neither of those two work, so now we go to the force, and we can go to this formula over here, which is equal to MA. Force is equal to MA. Hopefully you know that your M is in kilograms, and your acceleration, the A, is in meters per second to the minus 2. So you're going to get kilograms meters squared, because you've got a meter there and a meter there, S to the minus 2, so it would give us D, would be the correct one. Next question, question 2. An object falls for a time 0.25 seconds. The acceleration of free fall is 9.81 meters per second. The displacement is calculated. Which of the following gives the correct number of significant digits for the calculated value of the displacement of the object? Okay, so when you decide on the number of significant figures, you always look for, in all your data that you are using, you look at it and you see how many there are. So if I look here, this is actually 2 SF, and here we've got 3 SF. And so when I'm calculating, I've always got to go to my smallest, so it would be B. That is the smallest one. Fine. So question 3. Question 3. A raindrop falling from rest at time t is equal to 0 reaches terminal velocity. So you need to have an understanding of what terminal velocity is. Which graph best represents how the speed v varies with time? So terminal velocity, when something falls through air, the air exerts a frictional force, especially as it gets faster and faster, of a greater and greater force, until you get to a point where the force due to gravity is opposed by the frictional force, the force due to friction, and there is no net force. So the frictional net force, the resultant force, is equal to 0 newtons, and therefore acceleration is equal to 0 meters per second. So you're going to get velocity becomes constant, and that's your terminal velocity. So looking at these graphs, it can't be A, because A would be where you have a frictionless situation, and B is actually the correct answer. We'll come back to this. C here, you can see here that your acceleration, the slope of a velocity time graph is your acceleration. So here your acceleration starts at 0 and it increases, the acceleration increases and then decreases. Now that doesn't happen. When you drop something under the influence of gravity, it immediately accelerates at 9.81 or 10. And here, this over here, this velocity is not reaching a constant value, so B is the correct answer there. Question 4. Now we have a displacement d of an object, varies with time. The tangent to the curve at time t1 is shown. Okay, so we have this tangent over here. This line here is the tangent. I can't draw it very straight. So that line is the tangent, and then it says which of the following gives the speed of the object at point P. Now you need to know that for a displacement or a distance time graph, your slope of your graph, the slope, is equal to the velocity. If it's a displacement, if it's distance, it will give you speed. We're looking here just at the slope of the graph. So at that point P, to get the speed, we just need the gradient at p. The gradient of p. Another way to look at this, you know that this is measured in meters and this is seconds. So when we find the slope, we got our change in d over our change in t. That's how you change in your vertical over your change in your horizontal, and that's meters divided by seconds, meters per second. So we can see from our units too that we're getting a speed or a velocity quantity. Question 5. A ball falls vertically and bounces off the ground. Immediately before impact with the ground, the speed of the ball is u. That's your initial velocity. Immediately after leaving the ground, the speed is v. Which of the following expressions is the ratio of the kinetic energy lost on collision and the kinetic energy immediately before the collision? Alright, so let's have a look at EK lost. So EK lost would equal your EK for the start. Oh, it would actually be a final. Let's use a final minus EK initial. So that would equal a half mv squared minus a half mu squared. And that will give you your change in the, that will give you a lost in the collision, your final minus your initial, or your initial minus the final. Probably it actually, to give, when we're talking about loss, because we're going to have more kinetic energy before, let's do this like this. Let's do u minus v. I think that's going to help us the way I can see the formula turning out here. And then you divide it by immediately before, that will be equal to a half mu squared. Now the reason why I'm using that formula is obviously because I've got that in my data booklet, isn't it? That's my kinetic energy over there. So I can factorize the half m, and I'm going to get u squared minus v squared divided by a half mu squared. The half m can then cancel. The u squared and the u squared goes 1 minus, and we still got this one, so it's going to be v over u all squared. So we have this d over here would be correct. Okay, going on to question 6. It says a railway engine of mass m moves along a horizontal track with uniform speed, so it's not accelerating, therefore there must be no resultant force acting on the train. The total resistive force is F. Which of the following is the power of the engine? So the power, if we go here, we've got this formula over here. Power is equal to Fv. Because this force that's been applied by the engine is purely to overcome the resistive force. That's all that, because you're going at a uniform speed. So it's just applying that force. So that's why we have that Fv. So it would be B, would be correct. Question 7. A ball is tied to a string and rotated at a uniform speed in a vertical plane. The diagram shows that the ball at its lowest position. Which arrow shows the direction of the net force acting on the ball? Now, because it's going at a uniform speed, all the change in velocity is due to a change in direction. That's what's actually causing the acceleration. So it doesn't have any force that's actually accelerating the ball in that direction. That will remain constant. So we just have the force that to the center. So with circular motion, your force is always towards the center of the circle, like that. So that will be your force. So it will be A is the correct answer. Now this next one is a little bit tricky. Let's just see how we handle this. So it says a gas atom strikes a wall with a speed v at an angle theta to the normal to the wall. The atom rebounds at the same speed v and angle theta. Which of the following gives the magnitude of the momentum change in the gas atom? Now we're going to need to split this up into two components. We're going to have our horizontal component. We're going to have that one there as it goes, and our vertical component. So let's have a look. This is before, and let's have a look at this as after. So your V in this direction, your V horizontal in that direction, V1 I'm going to call it. When we look at this triangle here, we can use simple trigonometry. We've got V as our hypotenuse. We've got this, we're looking at the adjacent, so it's going to be V cos of theta. Your vertical is going to be V sine of theta, and that's for 1. So V1 in that direction going down. Now when it's coming out, you can see now that in the horizontal direction you're getting a change in direction. Now the velocity V2 here is going to equal minus V cos of theta, and this one over here will still be the same. This will actually still be going the same direction, so that's going to be V2 will equal to V sine of theta. So we see that there's no change in the vertical. The velocity doesn't change, so the momentum, the change in P in the vertical is 0, but in the horizontal we do get some change in momentum. So the change in momentum is equal to our final minus our initial. So we're going to get P final, and which is mv final minus our m. So let's call this mu. We have that formula there. So we're going to get, for our final, we're going to get minus v cos of theta, and that's going to be minus m v cos of theta, and then we're going to be minus m v cos of theta. So we're going to get there minus 2m v cos of theta. Now because they said the magnitude, we're not really interested in the direction, and the plus and minus signs is just giving us direction, so we don't need to worry about that. So we just got this over here, so it's actually going to be D will be the correct answer there.